Okay. So between mass and energy, right? So whatever
Yeah.
the changes that are taking place, right? So they are going to, to be linked with mass and energy, right? Take it.
Yeah.
So this is all about physics, right? So we deal with the matter, deal with matter and the changes, right? Again, I can say in this way, and the changes occur, and the changes occur related to matter. So do you think that mass, energy, they both are related to matter?
Yeah.
Yes. Okay. So before, physics, in physics, we always talk about the measurements. We always talk about the observation. Whatever you observe, okay, that is all about physics, right? So,
Yeah.
for example, right now you are taking class, right? You must be sitting on the chair, right? And you are,
Yeah.
you are observing things. Okay.
Yeah.
So now you are not moving. You are not moving. That means we are considering the, state of the body. Yeah. We are
Yeah.
considering state of an object, right?
Yeah.
So when we say that we are considering state of object, so state tells us this state can be at rest or can
Movement.
be a movement that is called motion, right? Okay.
Yes. Okay.
Are you getting my point?
Yep.
Right. So how many things that are surrounding you, they are moving and they are at rest?
All of them was.
All of the things are moving, like
No.
fan,
Yeah.
fan.
Yep.
Okay, right. And other than fan, what is moving?
What is moving? For example, a human. The
Oh,
air is
okay,
moving.
human. Air particles are moving, right? Okay, so you
Yeah.
have talked about state of one of the state of the matter. Right. Okay. So we are going to start our topic from movement and position, right? Movement
Yeah.
and position. So the very first thing that we will be discussing, movement and position. All right. So when we talk, the object is moving. When we say object is moving, so how can you say that object is moving? For example,
Uh.
let me give you one scenario. There are two cars, right? There are two cars, okay? And one car is moving with 50 km per hour, right? Another car, another car, right? That is also moving with 50 km per hour, right? So when
Yeah.
they see each other, so what do you think? What are they going to feel?
If they're both going at 50 kilometers per hour, both of them will feel like they're not moving.
They're not moving, right? So that means it is the frame of the reference, right? It must be
Yeah.
in the frame of the reference ticket with respect to what you are, considering you are observing that object, right? So if you are saying that humans are moving, right? So that means you are comparing with your state, right? With your own reference. Okay.
Yeah.
So if one object is moving, another object is moving, that means you are comparing with your own observation. Okay. So movement is something that must be, observed with the reference. Okay. Movement movement is something that is observed with respect to reference. Okay, with respect to reference, right? Are you getting my point?
Yes. Yes.
Okay. So, Acha, are you able to observe what I'm writing? Because maybe my words are not enough
Yeah.
visible. Maybe
No, it's
are
clear.
are
It's
they
clear.
are they clear? Okay, well done. Right. So when we talk about position, right? When we talk about position, so that means the change of the change of the the change of body from one point to another point, right? Okay, so that
Yeah.
also, that also refers to the movement as well, right? When we talk about that body is moving, that means that body is, moving from one point to another point, right? So the body must cover some distance, right? The distance
Yeah.
should be covered. Distance must be covered, right? So now my question to you, what is distance?
The distance is let's say distance is from like
Yeah.
the measurement from one place to another.
Okay, so distance is the length between 2 points, right?
Yeah.
We can say the distance it is the length
Length.
between 2 points, right?
Yeah.
Okay, and there should be the unit. Whatever we measure, there should be the unit, right? So when we measure things, it must be defined with the specific unit, right? So
Yeah.
it's SI unit, it's SI unit
Meter.
is meter, right? Okay. So what SI means? That is some system,
Standard.
yeah, standard unit, or we can say system international. System international, right? The standard that is, defined international. Okay, so when we say distance is covered, so if I consider how much time the body has taken to cover that distance, right? How much
Yeah.
time the body has taken to cover that distance. So will it give us another quantity?
Yeah.
Okay, so if I say that distance, okay, let me discuss in this way, that if I say that you are moving with the 50 km/h, right? So that means
Yeah.
that you have got this kilometer, that is a unit of distance, and this hour tells you the time. So if we are considering the distance and time together, distance, distance traveled, distance traveled or covered, right?
Yeah.
Per time taken, right? Time taken.
Yeah.
So that will give us another quantity. That will give us
Yeah.
another quantity, which is the speed.
Speed.
Yeah, that is speed, right? So whenever we want to move the object, we want to change the position of the object, what do we have to do?
When you have to, so can you repeat?
Yeah, in order to move any object, in order to, change the position of the object, what do we have to do?
Uh, I in terms of the object, it must
Okay,
have
yeah,
energy.
energy. Okay, so from where that energy, is taken in?
I don't know, from kinetic energy.
Okay, kinetic energy. So, okay, from where the kinetic energy is coming?
Uh,
All right. So, let me rephrase it. You are sitting and you want to move that any object, right? So,
yeah.
what do you have to do?
I have to apply force.
Excellent, right? So that's needed, right? So force is
Yeah.
needed. Whenever you want to move the object, right? You want to move the objects, right? So you will always apply force. You will always apply
Force.
force. Okay. So what is force?
Force is. How can I explain it?
Okay, all right. It's the agent, right? You can say it is the agent. It is the agent. Force is the agent that 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 changes the position, right? That
Yeah,
changes the position. Either we can say this, or we simply say it's a push or pull. Okay, push or pull. Either you push the object or you pull the object. Are you getting my point?
yes, yes.
Yes. So, and can we measure the force?
Yes.
Yes. Okay. So it must be having the specific unit, that is SI unit of force is SI unit of force is Newton, right? Newton. And the symbol is capital N, right? Okay, so the things are, are expanded in this way. We started off with the, you know, the movement and position, right? Our observation, and then we discuss distance, and then we come to the force, right? So
Yeah,
that means in order to move the object, force is needed, right? So here is the object, you apply force, right? And the object, is accelerating. Clear?
yeah,
Right? Are you getting my point?
yes, 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 yes.
Right? So
Hello.
the object is going to be accelerated, right? So
Yeah,
when you apply a greater force, what will happen? If you keep changing your force and if you keep increasing your force, do you think that the body will also be accelerated?
yes.
Yeah. So can I say the body is speeding up? Speeding up.
Yeah,
Yeah. Okay, so I have got this point, and I have reached to that concept that whenever the speed is increased, the acceleration is produced, right?
yeah,
Yeah. So let's conclude some definitions, right? Speed is what? Speed is defined. Speed is defined as the distance, as the distance traveled per unit time. Got it? Per
yeah,
unit time, right? Okay.
yeah,
So if the speed of something is changing, it is accelerating, right? Or decelerating, right?
yeah.
If speed is changing, I'm not saying that speed is increasing. I'm saying if it is changing. So change could
Yeah.
be, it could be increased or could be
Or decrease.
decreased. Yeah. So speed is changing, right? So that means it is speed is changing, then the object is accelerating or decelerating, right?
Yeah,
Clear? Okay. So if I say the object, if we know the total distance and the total time, right? For example, you are living at A. You are living at point A, right? You go to
yeah,
your friend's house, right? And then you cover some distance, right? And then you from your friend's house, you go to school, right? Okay,
yeah,
and then you come back to home, right? This is how you take this journey. Okay, now
yeah.
if I say that, would you consider that you are going to move with the same speed throughout your journey?
It's very,
It definitely it will vary, right? Okay,
yeah,
so you probably cover this distance in maybe in 25 km per hour, right? Maybe you cover this distance in 35 km per hour, right? And maybe you cover this distance in 45 km per hour, right? So this is how you take different speeds, right? And it depends on 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 the roads, on the traffic, and different parameters, different other conditions are involved. This is how you change your speed, right? Okay, are you getting my
Yes.
point? Yeah. So,
Yeah.
but you going to say that you are moving with different speed, right? But I want you to have the one speed. So is it possible? Practically, is it possible to have the one speed, a constant speed?
Yeah, you can.
It is not possible, right? Because other conditions are involved in real life situation, right? So we are going to be introduced with the average speed, right? So we should get the average speed concept. What average speed is? If we know, if we know total distance, right? Total distance and a total time. Clear?
Yes.
Total time taken by the body, right? So that's how we can, take the average speed. Okay, so if we say that object is moving with the uniform speed, so it could be a average speed as well, right? Okay, so for average speed, we will be considering the total distance covered by the body, total distance covered by, or you can say total time taken. Total time taken. Are you getting my point? Anything is
Yes.
difficult? No. Okay.
No.
All right. So, Acha, when I say that the body is covering distance in a specific direction, so is there any quantity that is somehow related to a distance?
Uh,
When
if it's
I
going in
when I say direction is specified, the body is covering distance in a specific direction. So can I, link with another quantity that is related to distance?
displacement.
Yeah, displacement. Okay, well done. So that means displacement is nothing but a vector quantity. Displacement is nothing but the distance covered by the body, distance covered by the body in specific direction, right? Okay,
Yeah.
so I hope you are getting my point. So this
Yeah.
displacement is nothing but the distance covered by the body in specific direction. For example, I say Hamza has covered 50 kilometer towards east, right? Okay,
Yeah.
so that means that this direction is specified. That's how the distance has become our displacement. And remember, distance is the magnitude for displacement. Distance is what?
The
Is
magnet.
the magnitude for displacement. Is this clear? Yes?
What does magnitude mean?
Magnitude. Oh, okay. All right. So you apply force. For example, you apply force. Okay, just understand magnitude. Then we will discuss other things. Magnitude. In terms of force, if I say force is applied, that is 3 Newton, right? Your weight, let's say your weight is uh 500 Newton, right?
Yeah.
So this 3 is the magnitude. This 3 is the magnitude. The quantity.
Oh.
This 500 is the magnitude, right?
Yeah. Yeah.
Okay. So let's say the average temperature is 29 degree Celsius, right? So this 29 is your magnitude, right? Are you getting my point? and degree Celsius is the unit.
Yeah.
Again, this unit N is the unit. Clear?
Yeah.
So distance is nothing but what? A magnitude for
Yes.
displacement. See over
Yeah.
here, I have written 50 kilometer, right? So this is your what? Magnitude. Clear?
Yeah.
And this east is the what? Direction.
Yeah.
Clear? This is how the distance has become a displacement. ठीक है जी. All right. Okay, so let's introduce with another quantity, that is the velocity. I have talked about the speed, I have talked about the distance, I have talked about the displacement. Now this time for the velocity. So what is velocity? Any idea
Uh,
velocity?
velocity is like, I think, the scalar unit.
Okay, it's a vector quantity. Okay, it's a vector
Oh yeah.
quantity, right? And as I introduce the displacement in terms of distance, right? As I introduce the displacement in terms of distance, I can introduce the velocity in terms of speed, right? How?
Yes.
When I say the speed of of any given object is, is given with specific direction, right? The speed,
Yeah.
the speed given with any specific direction, then it is velocity. It is velocity. Clear?
Yeah.
Or we can say the rate of change of displacement, or we can say the rate of change of displacement. Okay, displacement. Why? Because the displacement has always direction, right? Change of
Yeah.
displacement per unit time.
Yeah.
Per unit time, it's going to be the velocity, right? So it's the same thing. S is going to be your displacement. T for the time, right? Time taken.
Yeah.
And V is for the velocity. The same symbols are also used for the speed. In case for speed, right? Speed, that is the distance upon time, right? Distance upon time. So speed is what? V, distance is S, and T for time. Clear? The same
Yeah.
symbols are also used for the speed. Taken?
Yes.
Right? Okay, so let's come to the acceleration, because I have talked about the acceleration here, that when you apply force and the object is accelerated, right? So that means it is
Yeah.
speeding up. So what acceleration is? Let's talk about the
Yeah.
acceleration, right?
Yeah.
So it's going to be related to the velocity, right?
Yeah.
Acceleration. So acceleration is, again, it is the change. It is the change in
Velocity.
velocity. Yeah, in velocity per unit time. Per unit time. The SI unit for speed or velocity, SI unit for speed or velocity is meter per second, right? Or you can
Yeah.
also, you can write in this way, clear? Meter per second, and you will read in the same way, meter per second. Got it?
Yeah.
Okay.
Yeah.
It is the change in velocity per unit time. So change in velocity. Again, you can say velocity is V divided by time, right? It's going to be your acceleration. Okay, clear? So Asha,
Yeah.
in some books, you probably see this delta. That delta tells there's a change. Okay, there's a change in velocity, right? Are
Yeah.
you getting my point? This delta is nothing but that only tells the change. Okay, whenever we talk about change, so we can put a delta here. Okay, change of velocity, right?
Yeah.
Actually, now, what should be the SI unit of acceleration? We can drive from here, meter, meter
Per second squared.
per second. Okay, and
Squared per second.
it's, yeah, or it's going to be what? upon
Me.
second, right? So if I say, if I shift this second to the numerator, so will I get? This s to the power negative. This positive power will become negative power, right? Because I have shifted
Yeah.
to the numerator side. So this meter dot second square. Got it?
What's a dot?
It's nothing but a multiply meter.
Oh, okay.
Okay. It's nothing but a multiply.
Can you also say meter per second square?
Yeah. Very good. Exactly. I mean, it is like that. Meter per second square. Okay. If you are
Yeah.
putting, if you are, putting the second square in the denominator, so that you are going to use a positive sign with the power. If you are using, if you do not want to drop the second to the denominator, then you have to show a negative sign with the power of the second. Okay. I
Mm.
hope that you got my point, right? Okay,
Yeah, yeah.
so we can also write acceleration is nothing but a change in velocity. So what what do these represent? This v and
V
this u.
V is final point.
Yeah, so final speed, right? Final speed. Okay, or
Yeah.
final velocity. I can also say final velocity. Got it? And u is all is considered as initial velocity or speed. Got it? Clear?
Yeah.
And time is, time taken. Right. I hope this is clear to you. And
Yeah.
there are three equations. Okay, there are three equation of motion that you need to you need to practice. These formulae will be given to you in the exam, but you have some things it is better to keep in your memory, right? Because
Yeah.
they will keep they will make our things easy when we do calculations. Okay, so
Yeah.
uh first equation of motion, first equation of motion first there are three equation of motion basically, right? And we, it's not a standard. It's not a standard that yes, there are always three equations of motions, right? In some books, they are not defined in this way, right? In some books, they are defined in different way, right? So it's better to you can just understand the concept. Uh, Equation of motion. You simply say it. Equation of motion, and I'll be discussing the detail that how can these equations be applied when we do the calculations. Okay, so the first equation of motion.
Hello.
Yes, and the second equation of motion is going to be uh s uh, s is equals to v t minus 1 upon 2 a t squared. Okay, and I'm not saying that you have to, cram it, you have to memorize it. I'm just saying that yes, these equations exist and you are going to apply in different scenarios according to the, data that is given in the question. Okay. And the third equation of motion is going to be 2as v square minus u square. Okay. So let's understand these symbols. Okay. This s is a distance. Okay. This v is the final speed. Are you getting my point? Yeah.
Yeah, yeah.
And t is the time. A is the acceleration. And t is the time. So again, t, square of the time. Acha, the, examiner is not demanding you to, to explain that how these equation of motions have been derived. Okay. So you do not have to, explain in detail. These equations, these formulae will also be given in your paper, right? Okay, in data booklet, right?
Yeah.
So you just need to understand that the meaning of these symbols, and in next class we will be doing some questions where we are going to apply these formulae. Okay, and again this S is distance, V is velocity, sorry, it's final speed, and U is initial speed. Again, this A is for acceleration, B is the final speed. I hope you got the idea that, I mean, there's nothing other than distance,
Yeah.
final speed, time, acceleration. There's nothing other than these. Okay.
Yeah.
Initial speed, and again, you have got this, the T is the time. Okay, so in the next class, inshallah, we'll be doing some questions related to this, right?
Yeah.
I'll be discussing graphs as well, right? So graph of distance time. We will be discussing graph of velocity time, and then inshallah we'll be doing some questions that how examiner asks the concepts, right? Okay, so if there is
Yeah.
any confusion that is not clear, you can ask me. Acha, after every class, inshallah, you will be getting the recording of the lesson, right? So you
Yeah.
can, if you want to review things, so you can do it. Okay,
I just have one question.
yeah, sure.
Can you go to the last one, the all the equations?
Okay, yeah.
Yeah. One, for example,
Mhm.
for the last two, the S equals VT and then 2AS equals. For these two, what type of questions will come when they ask
Okay,
this?
so when the distance, okay, good question. See, in this one, there is no distance in the data, right? Over here, you can see when there's no initial speed is given to us, right?
Yeah.
And over here, you can see when no time is given to us in the data, no time is given.
Yeah.
So upon different scenarios, we are going to apply. Okay. So if they ask us to find out the acceleration and they have not given us the distance, so we have to have the final speed and the initial speed. Okay, right?
Yeah.
If they are asking to find out the distance, so we can find a distance from the second or third one, right? But now we have to identify if the time is given in the question. If the time is not given, so we cannot use this one. We have to move to this one. Is this clear?
Yeah.
Okay, this is how we are going to apply,
Yeah.
right? So these equations are, coming from the same scenario. The equation of motion says that the body has to move, right? If the body is not moving, so these equations cannot be applied. Clear?
Yeah.
Got it?
Yeah.
Okay. So hope you have got the idea. And inshallah, in upcoming class, the next class, inshallah, we'll be doing the graphs, right? And we will be discussing gradients. Okay, right?
Yeah.
चलिए
Yeah.
ठीक है बेटा ओके अल्लाह हाफिज अस्सलाम वालेकुम टेक केयर
Alaikum salam.